Mean value theorem. We're going to spend about 15, 20 minutes reviewing what the mean value theorem is and what it does, and a couple of FRQs on it so that you're comfortable with having seen it before. Mean value theorem says that if f is continuous on a closed interval and differentiable on an open interval, then there exists a number c such that f prime of c is equal to f of b minus f of a over b minus a. So first off, this f of b minus f of a over b minus a is your average rate of change. If it asks you to find the average rate of change, then that's what it's asking you to do. We also use this f of b minus f of a over b minus a. We also use it sometimes to estimate f prime at a particular value. We use it sometimes if it asks us to find f prime of 5, and we don't have f prime of 5, but we have f prime of 4.5 and f prime of 5. Sorry, f of 4.5 and f of 5.5. Then we basically, this is a slope formula that we use to estimate f prime at that value. So that is that's another use for this f of b minus f of a over b minus a. It's basically just a slope formula. So that's how you can remember that it goes with derivatives and rates of change, because that's what derivatives are. But this average rate of change will be the slope of the secant line. So here's my 2 points. And it's saying that the slope of the secant line matches up with the slope of the tangent line at some point. Okay, that's what it's saying. Now, your steps, the things you need to do for a mean value theorem problem. First thing you need to do is you need to say that f is continuous and differentiable. Usually that is said either, because that's the kind of condition that needs to be fulfilled in order to use the mean value theorem. If our function's not continuous and differentiable, then not mean value theorem. Mean value theorem doesn't apply. So like a counterexample would be like there's like an absolute value type of thing. This would say that f of b minus f of a over b minus a is 0. So at some point the slope has to be 0. Well, it's not because of this corner. Now, if it were just a curve, then yes, the slope would have to be 0 at some point. So we need to check that f is continuous and differentiable. Usually that's done either it tells you that the function is differentiable, so you would say that because f is differentiable, f is continuous. Differentiability implies continuity. Or you're just told the function, and it's easy to say, hey, that function is continuous and differentiable. Like, hey, it's a polynomial. Polynomials are continuous and differentiable. Or sine of x is continuous and differentiable. Or, again, it's saying that it's differentiable, so you say that because it's differentiable, it's got to be continuous. Find f of b minus f of a over b minus a. And then step 3, make your conclusion. So your conclusion should say, therefore, by the mean value theorem, there must exist at least one point where f prime is this value. Usually you'll know what to write because it'll ask it in the question. You'll see what I mean in just a minute. Okay, so let's look at a couple free responses, and I'm only going to focus on the part of the question that's the mean value theorem part. We can focus on other parts another time. All right. First off, take a moment and see if you can pick out where the mean value theorem question is. They like it in a table. I noticed that because I was sitting here trying to find one that isn't a table for the sake of variety of questions. And I was like, there's a table, there's another table. Not that they don't ask it in other formats, but a lot of the ones I found were on tables. So we're doing some tables. In some form, it's asking, is there a time where the derivative is a certain number? If it's asking, is there a time where the function is a certain number, that's intermediate value theorem. That's a question that's asking, that's my theorem that says if I start at the first floor and go to the fourth floor, then I have to have gone to the third floor. Right? That's about the value of the function. If it's asking about the value of a derivative equaling a certain number, then that's a mean value theorem question. So first off, I'll label it as step 1 in this case, but you don't have to label it in steps once you're comfortable with it. First off, we have to say that it's continuous and differentiable. Well, it's a differentiable function. So you're going to say that C is differentiable. Implies, that arrow is like a mathematical symbol for like this implies, or this will mean that C is continuous. Okay, step 2. Since we are going from 2 out to 4, well, that tells me what we need to calculate for the f of b minus f of a over b minus a. That means we want c of 4 minus c of 2 over 4 minus 2. And I really hope that we get 2. If we don't get 2, then we need another plan. Let's see, on the table. C of 4 is 12.8. C of 2 is 8.8 over 4 minus 2. 12.8 minus 8.8 is 4. 4 minus 2 is 2. 4 divided by 2 is, oh, look at that! It's 2. What a coincidence. So I'm writing a little step 3. You don't need to write it as steps. Therefore, by the mean value theorem, you need to say that you're using the mean value theorem to get the point. Usually the scoring sheet says like conclusion using mean value theorem. So you need to say mean value theorem. You can abbreviate it as MVT. There must be a time t from 0 to 4 at which c prime of t equals 2. You would write that sentence. So, new type of mean value theorem question. Here's the graph of f. Now, the part that's mean value theorem here is part D. We're going to find the average rate of change of f from -4 to 3. And it says, uh-oh, there's not a point for which f prime is equal to that average rate of change. Explain why this statement does not contradict the mean value theorem. Okay, so find the average rate of change. There's no point at which f prime is equal to that average rate of change. Explain why this does not contradict the mean value theorem. So from -4 to 3, that means we are figuring out f of 3 minus f of -4 over 3 minus -4. F of b minus f of a over b minus a. That's what it's asking us to do first. It's asking us to find that average rate of change. F of 3, well, here's a graph of f. So this is pretty easy. F of 3 is just down at -3. Minus f of -4. F of -4 here is -1. And that is -3 minus a -1 is going to be -3 plus 1 is -2. 3 minus a -4 is 3 plus 4, which is 7. So -2 over 7. And the only time where the slope here, in other words, the derivative, the only time where the slope here is negative is here, and that's a straight line which has a slope of down 1, 2, 3, 4, 5, 6, and to the right 2. So it has a slope of -3, and that's the only time that the slope is negative. So in other words, there's never a time where our slope is -2/7. So it's asking, why does that not contradict the mean value theorem? How do I know it's not differentiable? Where is it not differentiable? At 0. So since f is not, that's why you need to check whether it's continuous and differentiable before you do the mean value theorem. Mean value theorem doesn't apply, or does not have to apply, because our function is not differentiable. Question? They asked you to do this. Like that was a part of the question. So if they just asked to explain why the mean value theorem doesn't guarantee, then you could just write this part in blue or in green. But they asked for this part in blue because it said, so in blue, I found the average rate of change. And in green, I explained why the statement doesn't contradict the mean value theorem. So those are the two things that that part of the question asked me to do. Make sense? Okay. Any other questions on that one? We're asking, where is the acceleration? 0. There should be 2 intervals in your answer. How many of you found one of the intervals where I can prove the acceleration has to be 0? You got them both? 25 to 30 is one of them. So we are asking acceleration being 0. Well, the mean value theorem would be saying that if v of b minus v of a, because we're asking about v prime if we're asking about acceleration. So if there's somewhere where v of b minus v of a over b minus a equals 0, if that happens, then between that interval, between a and b, there's got to be somewhere where acceleration is 0. And yes, that happens from 25 to 30. It happens where the top is 0. In other words, it happens where v of b equals v of a. That's when v of b minus v of a is going to equal 0. So 25 to 30 is the first place, and the second place is at 0, and at 15. So somewhere between 0 and 15 by the mean value theorem, I also need to have a place where acceleration is 0. So at least 2 places. Somewhere between 0 and 15 it has to happen, and somewhere in between 25 and 30 it has to happen. All right, so that's another form of how the mean value theorem gets asked. Questions on that?